This is Ship It with Justin Garrison and Ádám Nash, a podcast about everything that happens after Git push. Ship It is brought to you by Fly.io, the home of changelog.com. Launch your apps close to your users all around the world. Learn how at Fly.io.
Hello and welcome to Ship It. I am your host, Justin Garrison, and with me as always is Ádám Nash. How's it going, Ádám?
Hi.
This episode has been fun to record. This is our third time trying to record this one for audio issues for various reasons. It's always fun to try to record things.
I blame your lack of hair.
I am bald now, and maybe that had jinxed it. It's very possible.
I think Riverside doesn't know what to do with the lack of hair, so we're having audio issues because you shaved all your hair off.
This is all AI generated now. My voice has been cloned, and that is why we had audio issues.
I low-key thought someone kidnapped you and was impersonating you.
Someone broke into my office and jumped on the Ship It recording studio and says, we're going to record this episode.
Okay, in my defense, I show up to the studio and your camera's black, and it's never black. Okay, you're always here before me, and then you're always doing something in your garage, and then I show up and it's black, and I was like, either this is the beginning of a Saw movie or something's wrong. And then you turn your camera on and you have no hair. I thought someone attacked you and shaved you or something happened.
I lost that battle. I lost the battle with age. Oh, my hair's falling out. It's fine.
You're not even that old. That's, you know what's funny though? You look really young. And I feel like you are my favorite big kid friend. Me and you are ridiculous together. So we'll just be young when we're 85. It'll be fun.
That's fine. I plan on never actually acting old. That's totally fine.
I don't think you know how to.
I would be a terrible. I'm still just gonna be playing Lego until I can't.
Sometimes I look around and I'm like, who gave me kids and let me be the adult?
Really, who gave me responsibility?
Yeah, do you ever just look around and you're like, oh shit, I am the responsible.
Yeah, it's just, when you first get that pager and you're like, you want me to what?
Oh, dude, I was terrified for the first year. Okay, terrified. I would have so much anxiety, and now I'm just YOLO.
But kids have no run book. I'm just gonna say 24/7 on call, no run book. It was terrifying.
That's why they should hire, especially moms. People always want to downplay the fact that people have to take off work and go have kids. And I'm like, yo, we are resourceful. We solve problems. And we live team no sleep. Okay. We are perfectly made to be engineers. Duh. We literally manufacture our own projects and then keep them alive. We are constantly on call. You're welcome.
You got PM, you have maintenance down, you are everything. That's full cycle. That's just
right. We be maintaining stuff, keeping them alive. Can we get some credit? Moms are made for this life. I was you know what? I've kept kids alive. Software can't be that bad, right?
Yeah, it's true. Speaking of shipping software, on today's episode, we have Ádám, who talks all about moving developer environments from a Kubernetes-based local development into Nix, Nix OS, and Nix package manager, whatever you want to call it. Really cool episode on just why they decided to go a different route from what production looks like, because usually the idea is you want your development environment to look just like production, and they found that's not the case. So stay tuned for that. But first, we want to talk about links of the week. As always, this isn't a news show. This isn't something that we're trying to bring you all the latest and greatest news, but we do find links that we want to talk about, and we found them interesting. So, Ádám, why don't you go first this week?
I love tech links. I just more the tech news rather. But also one thing I did want to say about our show with Nix is I thought that was a really good explanation of Nix, because I found several people trying to explain what Nix does at scale, and I thought he did a really good job of an overall explanation.
Yeah, it's one of those things that's really hard to trimmed down, partially because it means different things, right? There is an operating system, there is a package manager, there is an idea around these environments. But the thing that he points out in there was the dev env, which is a project built around Nix packages, which I found really cool. It's like, oh, I don't have to do this from scratch.
Yeah, so I thought he did a really good job summarizing kind of the functionality of it all and how it made it better for his developers, so I thought that was cool. I felt like I had a better understanding after he talked about it. So my link is NASA's new moon car for Archimedes astronauts will be inspired by Mars rovers. And you guys know how excited I get about space, so I'm super excited about this. This is going to be the moon car to explore the dark side of the moon. So that's really interesting, being that it's so cold on that side. What did you say it was?
-300 Fahrenheit, just about. And,
okay, but it's crazy because the pictures for the article look like it's kind of like if you took an ATV and a Mars rover and it had a baby. So I'm like, how are they going to stay warm? I mean, I know your spacesuits are warm, but...
yeah, hopefully they have some heaters in there because, if you're on the dark side, that is very cold. But I mean, on the light side, it's also very hot. So spacesuits are kind of amazing.
That is true. I heard that if you're like a certain height, you can't fit in the spacesuit, so you can't be an astronaut.
I imagine, like, in general, saving weight and space inside of spaceships is like physical space, not space is pretty difficult.
My best friend wanted to be an aerospace engineer and she wanted to like be an astronaut, and like she got like into Georgia Tech and started taking these classes, and then they're like, you're too short to be an astronaut. And I was like, rude, y'all couldn't just make a small like mini spacesuit? She would have been the most adorable tiny like mascot, like not mascot but like astronaut. Well, she would have been a really cute mascot that was an astronaut also because she's so like tiny, but like rude. Short people deserve to be astronauts too.
It's true.
And she'd be like super compact and like you could fit her in things. I mean, she could have been like the real MVP of astronauts. But anyways, I think this is so cool because they contracted 3 different companies. I know one is SpaceX and there's 2 other ones, but they announced the new concept car and they're building this for the Archimedes space exploration launch. So I just think it's going to be really cool to see the new generation of space cars and what's added to it. And I just want to know, like, are they running Linux in the software and like what's it built on and all the things.
Well, and NASA does have a GitHub. There is, some software out there that if you want to look at some of the open source software that like they publish stuff. And that's one of the cool things that I started digging into. It was like, oh, what's this written in? How does this run? And it's going to be embedded systems. And it's one of those, like, we care about memory and how much we're using, and bugs cannot be fixed easily. So all that stuff is really cool. Just seeing how they develop and build this stuff and how long it takes to kind of go from, we have a plan and we're going to send someone to the moon again, or robots or whatever, in a decade.
How amazing is it that you could build software that's going to be in the NASA's car that's going to drive around the moon? Like, that is so cool. There's also a Java, one of the coolest open source projects that I've seen is a NASA project, and it does a lot of simulation software and different things, but it's written in Java and it is an open source NASA repo. I think it's so cool that they open source and you can contribute to like NASA. Like, how cool is that? What if you contribute to something that's running in space? That seems so neat.
Yeah.
What's your link?
My link for this week is called Software Needs to Be More Expensive. And this is kind of a reaction to the backdoor and XZ thing that happened, the CVE that happened just a couple of weeks ago, about like, how do we make this better? And in this article, one of the major arguments is similar to what happens with the coffee industry, where coffee is, you kind of expect it to be so cheap at the end. We're like, I'm not going to pay more than $5 for a cup of coffee. That affects the entire supply chain. Like, everyone that works on it doesn't get paid living wages, because at the end result needs to be this, I need less than $5. And open source software is free. And how does that affect that supply chain of the people that write it? And even though it costs $0 to duplicate the bits, the maintainer's time is what's affected. And the people that are building features and creating new values or fixing bugs inside of the open source software does cost money, and those people need to be paid. And so this person is arguing that we should have some sort of discretionary fund for like any company that uses open source software. All their developers should have like a $50 stipend, and it just goes to wherever. And I think it's an interesting idea, but I don't
It's
think
an
that
interesting
money,
concept.
it just puts more money into the system. And I do think that would be valuable to some extent, but I do think that the outcome of that's going to be something like popularity contests between open source projects and a lot more competition between open source, which isn't really necessary because open source doesn't have to compete. The people that write it also don't have to maintain it. There are reasons that open source can exist. That's just because they want it to, and that's okay. Putting money into it also is like this level of how much money is going into it. If I'm only getting $100 a month, I can't make a living on it. But if I'm making, $10,000, like, oh, wow, this is a full-time job. Like I should just do this. And figuring out that balance for who's maintaining the software and how it's being maintained and paid for over time is a hard problem.
I almost think it's kind of like volunteer firefighters. Like on the West Coast, I didn't even know that people had volunteer firefighting until I got moved to the East Coast. So a lot of them will have a few firefighters who are paid like a full-time wage, and then the rest will all be volunteer, and they'll be called in to volunteer like when, something really bad happens or they need it, And I almost wonder if they could pay like maintainers maybe, or pay a certain amount of contributors, but I'm not really sure like $50 donations are going to make a huge difference. Like not just because of you could, depending on how many people contribute, I know $50 could be like, eventually grow to a lot, but I think the variety of open source projects, some need much more maintenance, some don't. It's really hard to have a one size fits all,
Yeah. And I mean, at scale with enough developers putting in $50, like maybe there's a lot of money going around, but also I help out on the Kubernetes infrastructure SIG, and like our bill for running Kubernetes tests is hundreds of thousands of dollars. Like that's just like to run the infrastructure. Like we just have to pay for it. And it's like, where does that money come from? Like thankfully cloud providers, put that money into it and say like, hey, you can run on our stuff. But like the maintainers themselves, the people running the infrastructure aren't getting paid for that work. That is all volunteer work. It's like, hey, we have bills, we have real infrastructure costs, but that's all the money's going to that. And so different projects will have different amounts of requirements for how much it costs just to test it and validate it and make sure things that run and release it.
Also, I love open source, but there can be a lot of gatekeeping. And then how do you pick who gets paid,
Yep. And I mean, the back door that happened, right? The XZ utility, like that was someone stepping up.
That is wild because that was a long game. It's almost impressive. Like at some point that will be taken into cybersecurity classes and taught, because that is the new Trojan horse. He contributed multiple contributions and multiple bug fixes before he created a backdoor. And it was a very creative backdoor that was built to like download binary, wasn't it? So it's not like it was a straightforward backdoor either, so it's really interesting. What mechanisms can you even put into place to do that? Because how long do you have to watch and not trust your, contributors at that point? And people need help.
Even the reports that came out that like there were other people adding comments to the mailing list of like putting pressure on the one maintainer to say, hey, you need to add someone else to be a maintainer. And it's like, those were fake accounts. Like these were just like the one
those
person,
were fake accounts.
Yeah. Like the one person was like putting pressure for like, hey, emails are free. Like you can make an email and a profile and say like, hey, I'm a user. I need this feature. And
I didn't even think of that. Is like some genius, like evil genius, bad actor. That could be a TV show.
So there's a lot in there that's just like, how do you trust this?
That's what I'm saying. Like, and like, can you imagine? We're trying to figure out how to make open source less gatekeepy and to allow more people in. But then you get people like this who spoil it for everyone. And we're trying to break down the barriers. And now we're like, do we need even more barriers? Like, this is wild. Also, open source is in a weird place right now with OpenTofu versus Hashi, like, and Redis, like, it just seems like nobody can agree on where we go forward and how we meld like corporate engineering power and money and open source. So I think, well, not just that, and then the EU law that like open source is working with. It's just interesting. Like, what does the future of open source look like after all this? Because there's a lot of changes happening and things are going to have to reconcile at some point,
And you mix that with just the ability to have computers write code that functions in sort of Gen AI.
That's another interesting way.
It's going to be a very interesting year, maybe 2 years, of what does open source look like when writing the lines of code is essentially like not free, but the effort is much lower. And like, well, do we trust certain AI or certain people or whatever? Like that's a really weird space. And licensing is like completely separate. Like that's all for distribution. Like who can use it and how do you use it? But yeah.
Well, and it's also more complicated because we don't know what the courts are going to decide for intellectual property that comes out of AI, right? So that's a whole nother thing. Like who owns that code when AI creates it, you know? And then also maybe you don't have a bad actor and maintainer, but what if a bad actor starts writing stuff into AI? You know what I mean? And then it gets AI to create bad code.
Yeah, if you think your build system is complex, try to track where that line of code came from that was generated from some LLM.
Sometimes I think that AI will make us more efficient, but it may also complicate things more than it's worth. You know what I mean? Like I don't know. It's going to be really interesting. I feel like we were talking the other day about how far infrastructure, like, you know, has come and how much it's changed in like the last like 5 to 10 years. And now we're about to go through a whole nother revolution of open source and AI and, you know, so it's interesting. Like, where will we end up later?
So speaking of writing code, let's jump into the interview with Adam and we will talk to you after.
Well, friends, I'm here with my good friends over at Synadia, Byron Ruth and David G. And as you may know, Synadia is helping teams take NAS to the next level via a global, multi-cloud, multi-geo, and extensible service fully managed by Synadia. They take care of all the infrastructure, the management, the monitoring, and the maintenance, all for you so you can focus on building exceptional distributed applications. But before we even get there, we have to understand exactly what NATS is. So Byron, when you get asked to describe what NATS is, what do you say? How do you explain it?
It allows an application developer to adapt and evolve their application over time and scale it based on maybe the unknowns that they have at the time that they started the application. How that manifests is really in infrastructure complexity, developer components that you have to bring in, whether they're, streaming things, storage things, whether there's operational complexities about multi-tenancy and considering the security, a consistent security model around how your client components can talk to one another. And once you start evolving your system, scaling your system, you're inevitably going to have to, especially at the connectivity layer, bring in load balancers and proxies and, network overlays and things like that. And NATS provides you that foundation that allows you to not need to introduce those additional things. You can Lego brick your NAT servers together to scale out to sort of a topology that you need or use a managed service that Synadia offers, for instance. And you don't have to add primitives that are very common when building an application like KV and object store and streams and things like that. That's all baked into NATS. And so what inevitably will happen is that you start out with something simple request reply, and that's fine. But you're going to need to adapt and scale depending on, your use case and your needs. If you start with NATS, I think it gives you a better foundation, not needing to introduce additional dependencies as you adapt and scale your system.
I've got a total curveball one here.
A curveball?
Yeah, total.
Okay, let's hear it.
Oh, please do.
I'm not going to talk about NATS. I'm going to describe what NATS is. NATS is an intergalactic ready video conferencing system, like your favorite sci-fi show. When two ships pull up side to side, they open a hail channel, they talk. They might not know what the language is, but the channel opens, communication happens. So what happens when you open a video call? Two people might talk, multiple people might talk, the ships themselves might talk. So what we're saying here is NATS gives software the ability to have point-to-point and point-to-multipoint communications irrelevant of where they are, irrelevant of how they're connected, and irrelevant of what languages the connecting software is written in. It's a video phone system for software. And if you want voice recording, you can have that as well. We can add your ability to make sure things and conversations are recorded for playback.
Yes, that is a curveball. Thanks, David. Well, there you go. Today's tech is not cutting it. NAT's powered by the global multi-cloud, multi-geo, and extensible service fully managed by Synadia is the way of the future for application developers. Learn more at synadia.com/changelog. That's synadia.com/changelog. Again, synadia.com/changelog.
All right, today on the podcast, we have Ádám from LastPass. Thank you so much for joining us, Ádám.
Thanks for having me.
Can you tell us who you are and what technology you're responsible for?
I'm a principal architect within LastPass platform engineering organization, and we are running our production infrastructure on Kubernetes. And obviously, we have our developers trying to develop for that platform. And we had Kubernetes developer environments, but due to struggles, we decided to switch it to Nix. So this is what hopefully we will talk today about.
Yeah, that desire to, hey, production looks like Kubernetes, so I should put Kubernetes everywhere is a real struggle. And the fact that we tried some things and moved to Nix is really interesting to me. And so you're responsible for specifically the developer environments or for the production environments. Which part do you do?
Unfortunately, my responsibilities, or luckily, it's a little bit broader. So basically, as platform engineering architect, we are doing both the cloud infrastructure, CI/CD, all the kind of stuff that you usually call DevOps. And we are also managing the developer experience and internal developer portals. So everything that is basically from DevOps to platform engineering and buzzword, this probably belongs to us.
So basically a sysadmin, right? We used to call that just like you did everything that was beyond the code. And
yeah, I mean, I usually try to label us as everything that is not feature development for the product.
So how does that play out? Like you have developers, they're going to ship something to Kubernetes, but they need to test something locally. And you mentioned that you were starting with Kubernetes and there was quote unquote struggles, which is a very, very loaded term. That can you describe how that kind of came about and what you were trying in the past?
Absolutely. So basically, I was using Kubernetes for like 6 years now, even before LastPass. And I also used Tilt and Kind at my previous workplace. And when I joined, then the developer environment was mostly Docker Compose. And they are running the containers, mounting stuff into that. And that worked somehow okayish, but obviously it wasn't without challenges. And obviously anything that makes a difference comparing how we run our software is making any development effort much more difficult. So like config differences, how you set up things and you don't test what you actually run in production never ends up well in my experience.
Yeah, using Docker is like this great boon for production environments. It's like, hey, we can ship something that's reproducible and we can distribute it with these registries. But also developers now have a much more complicated environment to spin up. And sometimes they can reproduce it easier, right? Because I can take a Docker Compose file from an open source repo or internal repo and say like, oh, just run all the components here. But how I get into those containers, how I manage and mount files into them, how I do all this stuff locally becomes really difficult. And when you add a layer of Kind or Kubernetes API on top of that, you're just like, oh, actually, I don't understand how big production is or how complex it is. I don't want to bring all that complexity to my machine.
No, actually, you don't want to do that. But if you start to build containers and you start to want to make it sure that the developers can have access to their debugging tools and everything, then you already start to differ. So then you will have like 2 container builds. And then obviously on LastPass is traditionally used PHP. So PHP is like Python. You don't compile it. You just mount it under the PHP runtime. But obviously, if you want to run a PHP container in Kubernetes, you won't mount your files into the container. And so then you already make differences. And obviously for like PHP, you even have to like compile the PHP runtime with like Xdebug flag if you want to do debugging. So again, that's will make the production difference. So this is adding up, and basically this is what didn't work for us. So wanted to try something else. So as I had experience, I did a POC on doing with on top of kind. Maybe we can run it with Kubernetes. Obviously, it can happen and we can make it. But the issue was more about the developer experience that the developers had. So like comparing to like saving files locally and then reflecting in the runtime instantly, we could like do syncing files from local to remote, but it's error prone. And if tilt breaks the syncing part, then it rebuilds the container, which takes a lot of time, especially if you have a ton of code. And this is the similar for front-end developers. Like, I mean, you can run the front-end locally, but if you start to move it into containers, then you have to compile it. So like you use the hot reload and every other nice things that they can enjoy in their local environment.
What made you pick Nix, and like, what is Nix, I guess?
So this is a very good question. So basically, Nix is multiple things. So you have the OS that is a Linux-based OS. Then you have the Nix CLI that is basically, sometimes they call package manager, but it's slightly more than that. So basically, this is how you basically interact with the whole Nix ecosystem. And you have Nix, the language, that is a purely functional, lazy evaluated language, which is usually the issue with Nix. To actually you have to learn Nix the language to use Nix the CLI, so you can build basically Nix derivations, which is we can call packages basically.
When Justin likes a technology or like knows what someone's going to say next, he has like this proud dad face. Like
my face was really just around, I'm hoping that I understand and could explain. I would love to be able to explain Nix the way Adam just did, because that was great. Because like Nix to me is that has the operating system, but then after that, it's like it always gets to this weird space. Like the definition of Nix seems to be the topic of Nix communities a lot of times, of like, what part of Nix are you talking about? And because it's the same word used over and over again for the language and these, I don't know if it's a package or if it's a tree of symlinks, whatever you want to call it. So why would you go with something like Nix that says, hey, we need to have this language that we need to evaluate and start running to be able to let developers run environments? What benefits were you getting with Nix that you were trying to eliminate in Kubernetes?
So that's two-thirds of our developers are on macOS. So if you ever run Docker on macOS, then you will realize soon that the SkyO performance is horrible. They improved a lot, but it's still horrible. And if you think about like running kind, and you're running your Kubernetes on top of kind. So basically you have a Docker VM that is running containers with the Docker runtime. And then within the Docker container, you are running a container runtime that will actually run your containers. So you have like 3 layers of abstraction, which is obviously hits your performance significantly. So you need much more resources than you ever needed for running them locally. So
what is Kind exactly?
Kind is an awesome project by the Kubernetes team, and that is Kubernetes in Docker. That's what it's abbreviating. And is basically running Kubernetes CI to test different scenarios. So for example, you can define multiple nodes with a simple YAML, and then different settings. You can install custom CNI. You can do a lot of things with it. So basically, it's better for like testing different failure scenarios or things like that. But also, it's very easy to start.
And I guess taking a step back for that development environment, like the main ideas behind, I want to develop something that's going to run in Kubernetes is you either bring all the Kubernetes stuff locally on your machine, and that's like you run kind locally, that gives you an API server, and then Redis or your database, whatever it is that you need to develop against, or you use another service that would like ship your code or mount your code to a remote Kubernetes cluster and say, oh, the Kubernetes cluster I develop against is over there, and I'm just mounting my file system and syncing it back and forth because I have everything running over there. And with Nix, you're just getting rid of both those things. You're just like, actually, this is just files on a disk locally, and we're going to develop it, right?
Absolutely. And actually, we were thinking about, okay, let's run it like, again, EKS or running vCluster on top of EKS or something like that. But at the end, we realized that obviously the team that deals with this environment has experience with Kubernetes, but most developers doesn't. And after running over more than 18 months this environment, we noticed that most of the developers doesn't contribute. They only have sometimes issues and they expect someone to help them fix it. Troubleshooting is hard, getting logs hard. You have to educate them how to use like kubectl, or let's download like K9s to have a better UI and everything, and it's adding up. And also because Kind was designed for like these throwaway clusters, so you basically start the container, you finish your testing and then kill it. But if you want to have persistence, then it's getting even more tricky, because then you have to basically simulate everything that the Kubernetes clusters usually do for you. So you cannot have like a proper CSI driver that is using some random cloud storage that auto-magically binds the volumes. You have to use like local storage. So to use local storage, then you have to basically bind mount something from the running Docker container into the actual Kind container. And then you have to bind mount that to the actual local file system you are running. Then you are running into file permission issues and all the magical stuff that Unix file system can provide for you.
Usually when you hear people talk about Docker and Kubernetes, you talk about them separately, like Docker versus Kubernetes. What's the reason to run Kubernetes in a Docker? I guess, like, what made that decision to, start there?
So basically, we wasn't prescriptive about what to use, but in my experience, is much more stable than the Kubernetes built into the Docker for desktop application. I managed to crash completely my Docker for desktop Kubernetes so much that I actually had to manually edit the config file because I couldn't even disable it. So on Windows, we had less issues with Docker for desktop Kubernetes. I'm not sure what's the difference between them, but on Mac, it was completely unreliable.
My guess, just not knowing the details, is Hyper-V on Windows is actually really good, and Mac OS's virtualization layer is not so good, and which is also a reason that I have run Linux forever. And performance-wise, it's great. But I want to get back to this, like, how do we talk about like Nix now? Like you're going to say like, we're going to throw away all that work, that 18 months or whatever that we were doing this stuff, and developers weren't used to it. And at some point, developers know how files work on a disk really well. And that's something that people can usually understand. But which portion of Nix are you using? You mentioned that it's an operating system, it's a language, it's a quote unquote package manager. How are you using Nix to set up developer environments?
Okay, so basically how we get to that we wanted to do this. So again, it started as a POC because we obviously want to listen to our developers, because even if we are supporting their environment, they are the ones that use them all day. We obviously run them, test them, whatever, but we are not developing in them per se. So they are the ones that experiencing all the pain that we cause them. I can say that. So we listen to their feedback, and because of the performance reasons and multiple other smaller issues that we couldn't fix, like the persistence. If you have like both Windows, VSL, and you have Mac, and you have to do this persistence through Docker and Kind, it's practically impossible to make sure that in every single environment it will work reliably and you don't run into local configuration issues. So basically, I was eyeing for Nix for a while, and there was a new project that was very, let's say, encouraging, called DevEnv. And DevEnv is a very nice way to get into the Nix ecosystem. So it's kind of abstracting away some of the complexity, but also giving you reusable parts. Like you obviously sooner or later want to have some other services than yours. So for example, you need like a Postgre MySQL database or Redis, or maybe you want to have some S3 storage simulated locally with MinIO. Then you can just basically enable that with a flag, and all the config is provided for you. And if you want to customize it, you can do it. So basically, it had the building blocks and it has the process manager to actually start it for you. So this is kind of an easy way to get started with a complex environment, I think.
So this is a wrapper on top of Nix for packaging. So basically, right, like it has a command line that interfaces to a config file. And you say, okay, devm up or something to start your environment, which is going to switch your libraries and your dependencies to the correct versions, as well as create services that you can access with whatever you're trying to program, right?
Yeah, so basically it has its own CLI, so you can use the very simple abstractions over Nix, but you are still writing Nix code. And the CLI has some benefits comparing to using directly, or you can choose to run it with the so-called flakes. That is a controversial topic within the Nix community. It's deemed experimental, but practically in the last 2.5 years, it got traction. So practically, if you run into any Nix repo, you probably will meet a flake.nix file. And this is how you can run without the CLI, this stuff. So basically,
what is I'm not familiar with I've heard the term flakes, but I have no idea what that actually does.
So basically, if you write an Nix file, then it has to be evaluated. And if you use the Nix packages repository, then basically you got all the dependencies of the whole ecosystem together. And basically how you can evaluate that, as I mentioned at the beginning, that Nix is lazy evaluated. So it only executes a code path when you actually want to access it. So basically, this is how you can load the whole Nix packages into memory, all the tens of thousands of variables, because most of the time it's not used. So it's not actually loaded into the memory unless it's evaluated. And it's a nice way to do this. But if you want to build the derivation locally, you write the function, you write the inputs, and you have to provide the inputs. And if you provide like Nix packages as an input to your derivation, then it will differ basically whatever you define Nix packages as. So the flake concept was a way to solve this dependency pinning issue. So in a flake-based project, you will have a log file that is basically pointing to a certain commit of the Nix packages or any other input. And that way you can basically get absolutely reproducible builds by not depending on local settings. I hope it makes sense.
But well, essentially it's a lock file. It's a way to lock your dependencies and say like, hey, we have every language net today has some form of lock file and say like, I want this version of this thing.
Yes, and it also defined a schema that is basically having inputs and having outputs. That's it. But the issue is that in every Nix expression, you only have a single input and you only have a single output, and you don't have basically anything in between. So if you want to have multiple input values, then you have to use like an attribute set, like an object. And if you want to have a multi-value output, then you have to use an attribute set again. Nix doesn't have too many types of variable because it's not a general purpose language. It's designed for building basically packages.
In the 5 minutes we've been talking about this, you haven't yet convinced me that Nix is less complicated.
Well, in a way, I can see how, you're not having to run Kubernetes and Docker and all of that, and it does seem simpler. But how do you balance that with learning a new language and like learning this new other system? You know what I mean?
I never said that Nix was easy. So,
oh yeah, none of this is easy for sure. But you're going to something that's at least a little more reliable or more reproducible for people, and to Ádam's point, like less resource intensive to run if we're running it locally.
Isn't it kind of funny though? Like just like going to scale and just going to different talks, and people talk about Dockers versus Kubernetes versus Nix and like all these things, and it's like essentially in a way they're all like ways to operate things and like virtual environments, containers, and all these things, but in a way they're also so different. They have so much that relates, but it's also amazing how complex they all can be in their own environments, I guess. Or I don't know, just amazing like how people make these choices and then you're kind of, I wouldn't say stuck with them, but like it sounds good and then you get in there and you're like, wait.
Yeah. So basically the language is simple, but you obviously have to understand like how to deal with functional programming, which many people struggles with because like there is no order in the execution. You basically execute whatever is resulting at the end. So you can easily write syntactically valid but completely unevaluated code, which actually doesn't even work until you hit that code path, and then it breaks the build. And sometimes these error messages are obscure, but I don't want to deter anybody from doing Nix stuff. So why we ended up with that? So basically, it's complex because it makes you deal with all your build complexities and all your environmental complexities upfront. So like with Docker, you can like, okay, let's build a Node.js app. So I will just use like Node.js latest, or I don't know, Node.js 20 from Docker Hub. I will copy my source code, run npm EI or npm CI, whatever you fancy, and then npm run build, and then yeah, you're done. Then you realize that you probably need multi-stage builds, so you will start to do that, and then you have to create like your own runtime. You have to probably provide Nginx and stuff like that to run your static app, or you have to use like, I don't know, Node.js Slim because you don't need Python for Node, but probably you don't care and you just use the non-Slim version. So basically it ends up somewhere, but basically you always end up much more dependencies. With Nix, you don't have any dependencies to start with, and then you have to declare all of them up front. So basically this is how it's getting kind of complex. So you have to have that build. Also, Nix builds running in a sandbox. So if you want to run like secure builds, then you have to be sure that how you are building your stuff. So the sandbox means that it does not have logs output. It does not have any user inputs during the build, and it also has no network. So basically, whenever you want to build something, everything has to be provided upfront. And this is where it gets tricky, that basically how you can provide these inputs up front and not run like npm install during your build, because you have to fetch all the npm packages that you want to use for your front-end build up front, provide it in some way, and then like use like an offline cache way of npm setup auto magically, so it will be symlinked together and provide the reliable build at the end.
What is a build in this sense? Because you're not building an artifact like a container, right? Or maybe you are still building. I mean, assuming you're still running in Kubernetes in production. So is your build step taking the Nix environment and taking the dependencies and putting it in a container, or are you building some other artifact?
Every Nix build results in a derivation, but what the derivation contains is completely up to you. I mean, obviously there is some standards, and this is what the ecosystem try to make sure that you will end up with the same results across the different stack. But basically the derivation will be a folder under Nix store path, and it will contain something that you declare there. So I don't know, if you have a Go app, then you probably end up with the store path /bin/ your package name, and that's all you got. But if you want to provide, for example, some config file next to it, you can still cp it into the out path, and then it will be in your derivation as well. But basically, whatever you end up with has been declared upfront and can be deterministically calculated upfront. So this is how it gets a hash. So if you change any of the build inputs, then the hash will change, so your output will change, which is kind of nice because in case of Docker, there is always some kind of impurity in the build process. Like you don't declare the image, the logs will have different meanings, and ultimately even tar is not deterministic when you are compressing the layers. So even the tar layers cannot be compressed reliably.
So I have a folder now. I ran a Nix build and I have a folder with some files in it that I can reproduce. And then what?
Then you basically can use it to execute the binary. So basically how Nix works is that it's not like Brew. So if you like use Brew on Mac or Linux, you install something and it will be available globally. In case of Nix, people usually don't install anything globally. They store it in the store path, and then for whatever they need, they include it. So for example, you probably have multiple front ends. One of them is like on Node 18, one of them is in Node 20, somebody experimenting with Node 21. And then you probably end up like using MVM Node Version Manager. And then people maybe install, maybe not. Maybe install the Node version with MVM, maybe didn't. Maybe you have the same minor version, maybe you don't. With Nix, you have your like shell.nix or flake.nix file with def shell attribute, and then you actually says that, okay, I want to have Node.js 20. And in that Node.js 20 with the log file, you actually get the same minor version regardless what you do. And if you had this like a year ago, and back then you were a Node.js 18, Then when you go back with the commit and you go into the shell, then you will get Node.js 18. You don't even have to care what was declared because everything will be work for you when you open the Nix shell. And when you exit, nothing will be installed per se in your computer because it's not in the path. So basically, all the tools that you use is basically symlinked and added to the path variables, basically simplifying it. And this is how you get like these isolated environments with Nix.
Do you know how that's different or similar to something like a Python virtual environment? Because that, I mean, it's not in my path. It's a isolated environment. I can declare my versions. I'm curious, like how those are different or compare.
Conceptually, I think it's very similar, but it works for basically everything. So, for example, like you want to run, I don't know, CloudFormation, then you can like include your AWS CLI. And then people doesn't need to like figure out like, okay, do I need to use V1, V2, which version it was working with, because there's obviously sometimes API changes and things like that. So basically you can get this reliability without people actually even have to like read the README and do the installation and then like ending up with different version because time passed by a few months, so they updated the package. So it's always kind of like a hit and miss how reliable like your install scripts or README to provide the same experience for everybody. This way you can basically automatically do that. And there is like the DRF project, which you can hook into your shell. And when you enter the folder, it automatically loads the environment. And when you exit the folder, it unloads everything. And then you have a clean slate.
Do you feel like Nix has improved developer life for your developers? And how did you train them to go from Kubernetes to Nix for it to be like a better experience, I guess?
Yeah, so this was one of the concerns that we had, that this is obviously complex and even less, I don't know, familiar to them than like Kubernetes, because like they can read Kubernetes. There is lots of resources, lots of videos to get help and lots of great educational content. With Nix, there is some gaps with the documentation, especially around flakes, because flakes are not considered stable, then the official documentation doesn't contain anything about this. So everything else is somewhere on the internet except the official documentation, which is kind of makes it difficult to use. But at the end, because everything is on the file system, so for example, you start a DB and you see it in your git ignored repository, like in the .dev/slate, that there is like, I don't know, a MySQL folder or like a Minio folder and my files are there. So like questions like previously, like, okay, how can I reset my DB to 0 and reinitiate it? It's simple. You delete the folder and that's it. So you don't have to explain that to people because everybody like use folders and know how to remove it. And then when like you want to, okay, I need to do some kind of script. So like they look into it and like at the end it's bash. So like, okay, I can write my shell script. Obviously not most of like developers like doesn't write 100 lines elaborate bash scripts, but they can write easily 10 lines of bash script that do what they want, and they can actually test it easily. They don't have to build a container, create a job YAML from some random templates, so they can run it and then figure out how to trigger it. But I have to re-trigger it, but it doesn't work like that. So basically, by having just the simple building blocks, we already see much more contribution from varying people that previously with the Kubernetes one, because the complexity is there, but for their problems, most of the time they can manage it because they see the configs, they can see the changes, and they can retest it. And building all the containers for a developer environment, because we have like a ton of services to actually run a full-fledged environment, probably took sometimes more than an hour. And even just to start from like a well-warmed cache, like a local container registry, probably still took like 5 minutes to actually start the kind cluster, because on Mac it's just slow, and even on Windows it's slow. With Nix, I start the environment. If everything is prefetched, it runs in less than 10 seconds, fully operational. Everything works. Everything started. All the database, all the services, everything is running. If I have to start from a cold start, nothing installed, probably depending on internet speed, takes like 15 minutes maybe. And we are still trying to improve that to be under less than 10.
we started the conversation with trying to make the development environment look like production. And I'm assuming you still have Kubernetes in production. And now you have a very big difference between local environments where they do development, which are simpler, but when they ship it somewhere, when it actually goes out and runs somewhere, it's a completely different mindset of how they're going to interact with that and debug things. How has that played out?
Before I reflect exactly to that, so you would say that, okay, running on kind and running on Kubernetes, and we run production on Kubernetes would be kind of similar. But actually, we struggled a lot with this. Not because it's so different, but because like in production, you want to have like multiple replicas. You want to have maybe auto scaling. You want to have network policies. You probably want to have, I don't know, service mesh or some sophisticated CNI. In developer environments, you don't need that. You don't want to deal with that because you already have enough complexity. And at the end, we ended up to remove stuff from our production manifest to dump it down basically for development. And that created a lot of headaches because you start to remove stuff and then you accidentally forget to remove something else and it breaks things. And to be honest, Kubernetes, even they wasn't similar. We believed that we could make it happen, but this was the kind of realization that it's having to have a simple dev environment is so different to run a production. Like you cannot like add tolerations or like anti-affinity rules or topology hints or whatever. You cannot add that to local because it's a single node at the end. So all of this magical stuff that Kubernetes can't help you with is gone. And you have to remove that. And this is adding basically even more variations. So to answer your question, with the Nix environment, we have a completely different set of problems. But at the end, you can build containers with Nix. So because at the end, OCI artifacts is basically tarbos with a JSON file. So you can do that. And you can actually do that reliably. So like we have immutable text in every container registry. And I was worried like, okay, if we rebuild the same code because somebody modifies the README and we want to rerun the CI for a README change, if it's not set up properly, then it will fail on the build push. But actually it didn't because the actual digest that build process generated was matching. So the ECR just told us that, okay, we have this and fine. So you can push it all green.
What kind of feedback have you got from your developers?
So actually, we wanted to make the transition gradual. So we first started with the closed beta. So we gathered feedback. That's what kind of got broken during the development, fixed it. Then we kind of opened the public beta. And at the end, everybody migrated away from the Kubernetes one, even before we closed the public beta titles. So I mean, the reliability, like we got feedback, like with the previous ones, sometimes it just didn't start and they have to troubleshoot it for an hour. And to be honest, we didn't even know what break locally between like yesterday, he shut down the PC and then next day it doesn't work. With this, I heard like, I can do my work because I can trust that I opened my Mac and in 5 minutes, everything is running and I can continue like front-end development. And also, as I mentioned, like syncing files is no longer present. So if you modify a PHP file, it's reflected instantly. If you want to do front-end development, everything on localhost. So you don't have to like hack around like port forwarding, what you expose with kind, you have to like do node ports and all kinds of stuff. And at the end, so if you're running a localhost, then all this like how to expose services for like a front-end dev is not existing because everything is exposed already. So you can run it. I want to connect to a DB. The port is open on my machine. So it's absolutely there. So basically, these are the troubleshooting issues that they don't encounter every day. So until it runs, most people doesn't care. And it runs because everything is basically reliable because we don't have like local issues, what kind of config they have. Everything that needs to be set up is set up within the environment and doesn't need to really provide a README file to like, let's go through this. No, you install, you start, it works, and that's it.
That's huge because, I mean, nobody wants to sit there and troubleshoot for 4 hours trying to figure out why your machine won't even work. And I mean, let's be honest, developers are expensive. And if they're not doing their job and they can't develop, then that's a huge waste of money and time. So Sounds like it's been really effective.
I mean, we had like issues that we troubleshooted ours, and at the end we figured out that there was like a new Tilt CLI version came out, and the developer downloaded the latest instead of the version that was mentioned in the README. And yeah, I mean, it happens with the log files. Basically, every CLI is provided for them, so they doesn't even have to care like what version. If I move back between commits, it will be checked out automatically. So even retrospectively, you can easily test that if that change broke something or not, because this will basically move with you when you're running in your repository.
One last question for me is, and maybe this is a misconception on NixOS and Nix, the package-ish manager. When I am developing on something and Nix makes those symlinks for a version of the CLI or whatever it is I'm using, you said that gets loaded into memory at not compile time, but at like when I'm looking at, I want to execute this environment or work on this thing. And long time ago, when I was first playing with Nix, it would do that with symlinks and set out that environment variable. But then if I open a new shell and I said, oh, I want to go work on something else that needs a different version, I couldn't, because it was like a global change. Is that a problem in these environments, or is that just because I was doing something wrong a long time ago? I mean, it's like one of the things that I always wanted to ask about Nix, and it never kind of came up.
I'm not a Nix expert. I'm just an enthusiast, but basically this is how Nix package is set up. So if you have a Nix packages commit, then you have certain versions of certain tools. If you update that commit, basically the new version of Nix packages, then you updated your desired tool and every other tool probably that is there. Globally. So this is sometimes a struggle. Obviously, multiple softwares have multiple versions. So for example, Node.js or Go has all their actually supported version. There is always like a default one, there is like a rule like which one they choose, but there is multiple versions. But if you want to have a specific version, then you have to do some workarounds. So for example, with Flakes, you can declare multiple inputs, and you can declare an input for a certain state of the Nix packages repository, and you can use from that input that certain dependency. It's increasing your memory usage, and it's slightly slowing down the environment, but at least you can actually make sure that you can pin to some version. And also there is some other workarounds like using so-called overlays for Nix packages or for any other input, which practically means that you are declaring your own stuff. And declaring your own stuff doesn't mean that you want to change even the versions. For example, in our case, we are changing PHP. Why we are changing PHP? Because PHP works by providing your necessary extensions, and the extensions have a default set, but we need more than that, especially for local environment. Like, as I mentioned, Xdebug. Xdebug is not part of the default PHP runtime because it's for development purposes. So if you want to have your own PHP versions, then you can like even overwrite what is in Nix packages locally, and then you can build it for yourself. And this is kind of the Nix guarantee that because the compilation is stored in the derivation, whatever you choose until you don't break the build, anybody can build the same version with the same output.
Well, Ádám, thank you so much for coming and explaining how this has been working for you at LastPass and making those development environments. If someone wants to learn more about this or reach out to you, is there a place that they should go? Do you have a social media or a blog or something like that?
Yeah, I have Twitter. I have a Blue Sky account, which I don't really use. And obviously, I'm in some of these Nix Discord as well. So there is multiple places to reach out for sure.
Well, we'll add some of that to the show notes. And thank you, everyone, for listening.
Thanks.
What's up, friends? I'm here in the breaks with Sama Alam Naylor from Sentry, Senior Developer Advocate. Sama, I want to talk to you about root cause. I know that getting to the root cause of an issue, even here at Changelog, can be quite challenging, but then we use Sentry, of course, right? So Sentry comes into play, and then suddenly we can see all the things, all the mystery behind the scenes. Talk to me about getting to root cause of an issue with Sentry.
See, what's really nice about Sentry is that it can point you to the exact line of code that went wrong. and all the things around it that led up to that. So the HTTP requests that might have happened and the status codes that you got back with it and the data that you got back with it or the data that you posted. Everything is in that issue view to help you diagnose the issue without having to even go to your code or go to your server logs. Everything is there captured for you. And alongside that, you also have the ability to use session replay, which combines what the user did on the web page, on the phone, on the device as well. So you can marry up the actions that led to it, all of the data behind the scenes, the HTTP requests, and then the line of code and the function and everything else that happened around it. And you can even see, for example, if the error came from like a dependency and not your code itself, because it will show you the exact kind of like dev error you would get in your console if you were running it locally. And that's just so valuable because, you know, especially as a dev working in these larger organizations with 1 billion microservices, you're running Docker locally to get like 1 billion microservices started and connected up to like run a checkout flow, for example, on your local machine. That debugging takes time. And also we know how difficult it is to replicate real user behavior in a development environment as well. And you don't need to do that when you have the insights that Sentry gives you and that points you to the root cause. It just makes like diagnosing bugs like instantaneous almost without having to go through the rigmarole of replicating it live. And it's a dream for people on call. You know, I used to be on call as a dev, you know, in the middle of the night, 2 a.m., I'd get a call. Oh, users can't check out. We don't know what's wrong. We had no error monitoring back then. I had no stack traces and session replay and all of that stuff. And I had to replicate it locally and probably fail at that. And oh, sorry, can't fix it. I need a team on it. We need like more people. We need an incident room. We, you know, remember the days of war rooms? Can you even call them that now? And so with Sentry, you don't need that. Like one person can look through everything, have all of the information they need, and then go fix it.
Okay, get Sentry, go fix it. Too easy. Check them out at sentry.io. That's sentry.io. And make sure you use our code changelog and you'll get $100 off the team plan, which is super awesome. Again, use the code changelog, get $100 off the team plan, sentry.io.
Thanks again, Adam, for coming on the show and talking to us all about how you went from Kubernetes to Nix. And the thing that I thought was really cool was just the fact that they boiled down all the complexity of running this whole like container orchestration system down to files. And it's just like at the end of the day, like people know how files work, and that is much easier to deal with than layers of containers and VMs and networks. And the more we can put into files on a file system, the kind of easier it is to reason about and debug.
I think that's a really valid point too, because when you're onboarding people, like majority of the people are going to understand and be able to kind of get on board and like innovate faster when it's stuff that concepts they've already kind of been accustomed to, you know?
So for today's outro, we actually want to talk a little bit about remote development environments because this is something that's kind of come and gone in waves with different products that have come out, and just wanted to like talk about what's out there and what we've been using or trying. And the kind of OG or the original like remote environment is just like a straight up RDP, like remote desktop protocol. Like you just have a client on your machine and you have a VM somewhere else and you just stream the whole desktop. Just like give me the whole thing, go full screen. And you're in that environment. It can be, you know, Windows, it can be Amazon Workspaces, it can be a lot of these options. I used to manage like a VDI environment, virtual desktop infrastructure environments. That was kind of how I got into being a sysadmin with Citrix. And so I was really used to like, oh, we can run a VM over here and we can stream the screen to you wherever you are on a thin clients. And remote desktop environments still can work that way. And it just kind of gives you the whole computer experience. You don't have to worry about like which pieces of this are here, which ones are over there. It's just like, oh, here's a big box and we're just going to give you the display portion of it.
I think this is again kind of is it worth the trouble? For something small, it's just so easy to SSH and use Vim if it's a small change.
Right. And that's the other, like, hey, if I don't need the GUI, I don't need all this other stuff. Like I do most of my developments via SSH and Vim. And that's just, I just use the console, and I always kind of kept the console as like my lowest common denominator. Like I can always get a console on something. And so I've done things where I've made code changes on my phone, and I regularly do programming on an iPad now, and then I'll be at my desktop, and it's
You and that iPad.
It's just, I always just SSH back to the desktop, and that's kind of my central points. And things like Tailscale and VPNs have made that so much easier to get access to the system from wherever. That like my iPad has a 4G connection or 5G, whatever it is, with Tailscale. And I'm just like, I can be anywhere.
He loves his iPad, y'all. He loves it.
I like the size. It has limitations for sure. There are things I cannot do and I want to do on it that I cannot do that I used to be able to do on a Linux laptop. But for distractionless, sort of just give me a console and Vim, like it's great.
I think if you're making a big code change, or it's something that involves formatting or multiple files, well, I don't know. It depends on how big the changes are, multiple files. Sometimes I do think remote desktops and being able to run an IDE on your virtual desktop is valuable. But 90% of the time, unless it's a big code change, I'm just too lazy and I'm just going to SSH in and use Vim.
Right. And like the size of the repo matters a lot sometimes, where it's like,
it does, because your performance is horrible if it's too big,
And that's where you really need something like a big IDE. And like VS Code has the remote server and code server, which is, you can have a web-based version of it, or even just like your local VS Code that can connect to a remote system over SSH. So
I want to love VS Code, but I just can't. I'm definitely an IntelliJ like PyCharm person, and I just can't do it. I'll download IntelliJ on a remote desktop, on a like dev desktop, and run it on a remote connection before I even attempt to use VS Code.
Yeah, every time I tried really hard for a few years to use VS Code as my main IDE, mainly for like demos.
I've tried plugins. I've tried everything. I don't. And like the fact that you have to save it when IntelliJ saves, don't be wrong, IntelliJ's had some moments where I was like, what are we doing? But for the most part, it just works better for my workflow and the way my brain understands things. What's your favorite IDE?
I've always just gone back to Vim. Like it's, people say it's not IDE, it's just an editor, but like the amount of stuff I put into it, I use LazyVim is kind of a framework on top of it, which makes it much more IDE-like. And actually you can run some VS Code
I'm going to try
extensions.
that.
And so I'm still getting used to LazyVim. I switched to it when I switched to this new job. So only a couple months ago, and so like I'm still learning keyboard shortcuts that are brand new to me, but a lot of like the fuzzy finding and file opening and management is what I liked about VS Code, where it's really quick to do. And because it's all terminal based, I have it in tmux, and I just disconnect from tmux. I go somewhere else. I come back to it.
What's tmux?
Tmux is a shell multiplexer. It's like a virtual terminal inside your terminal. So it's like when I disconnect from a server, it stays running. Like tmux is always there, and you can attach and detach from it from multiple systems, and you can even do it from multiple systems at once. And so I always have tmux open. I've always had tmux since I was a sysadmin, and that's like the first thing that I run on any terminal. And then when I SSH somewhere, I open tmux, I can disconnect. And if I get disconnected over SSH, tmux stays running, and everything I was running stays there. And I don't have to worry about like, oh, I can't close this connection, or I can't lose internet.
Isn't there a bash command that will keep your connection open even when your local may disconnect?
There's ways to keep the connection alive, but there are some things that like firewall settings and stuff that are always a little more aggressive. VPNs, firewalls, that sort of stuff kind of gets in the way. And so tmux is just a way to like always allow it to be available if I'm connected or not. And I can always reconnect in and then rejoin the tmux session.
I like it.
So yeah, I've used that one for a very long time.
Do you feel like Emacs fans are like a religion?
I don't know. I mean, I feel like Vim fans have a similar sort of fandom.
I've never met people that love anything the way people love Emacs.
I mean, it's like people love Arch Linux, right? Like as soon as you run Arch Linux, you have to tell everyone you run Arch Linux. And I feel like maybe Emacs is the same.
My best friend's kid does really love Arch Linux.
There you go. That's like, it's the troll. And it's actually, there's one for Dvorak keyboards as well, which I use a Dvorak keyboard. So now you know.
Tell them why, Justin. Tell them why.
Because I have limited mobility in my wrist from an old injury.
How'd you get the injury?
I broke my arm crowd surfing at a concert in high school, like a long time ago.
There are pictures on the internet. First, you have to see Justin's high school hair. First, that's where we got to start this. And then, like, guys, I was traumatized.
If you go to justingarrison.com and search for crowd surfing,
he traumatized me with his arm completely broken and going the other way. And I was like, not okay. And he did this on the same day he decided to be bald. And it was just a lot for one podcast.
There was a lot of stuff.
I was like, whoa.
A lot of new information.
I was not caffeinated enough for this information.
Yeah, so that injury has, like, I use a Dvorak keyboard because it's more comfortable for me. I also use a 45-degree angled keyboard because I cannot bend my wrist that way. So, but yeah, like in keyboard shortcuts, like not moving my hand back and forth to a mouse has helped me a lot, which is one of the reasons I use Vim.
You're so effective. Also, children, this is why you don't crowd surf.
It was fine.
Did you stop crowd surfing after that, or did you do it?
I stopped for a while.
You're like, I went back after a while.
I mean, it took a while for the bones to heal, and then I had to prove to myself that I wasn't scared of crowd surfing again. So we did it some more.
But why?
It's fun. It's fun. The last remote dev environments I just want to point out too are things that are fully browser based, where it's like you don't have this sort of remote connection, and it's meant for environments where it's like, maybe this is a Chromebook, maybe you don't control the environment. These work great in lab settings. We just did Scale, the Southern California Linux Expo, and people that came with workshops that were fully web-based had a fantastic time. When you had to clone it locally or rely on someone's local machine to set stuff up, it became a little more difficult. So
something's always broken when you have to rely on how something works different on your local.
Yeah, so GitHub has code spaces, which is really nice. It's integrated into GitHub. It's different than the code editor that's just in the web browser. So if you're on a repo and you hit the period key, it'll open the editor, but you don't get like a terminal. You don't get a full VM. You have to go to code spaces to get that side of it, which is great. It works for, doing a little more inside of the repo, especially if you want to modify like multiple files in a commit.
I really like the straight code editor when you just need to make something really small, like something to documentation.
Single file README. Yep.
Yeah.
I just do the code editor. I submit a pull request from that. Gitpod is another one. Gitpod is a self-hosted version, which integrates really well to GitLab, but it's a separate product.
Oh, interesting. I've never used that before.
Yeah, and it's very similar to code spaces where you get that whole like code server VM environments, and you can run it yourself. And so I tried that for a little while too, in my home lab Kubernetes cluster, trying to run Gitpod and see if I would want that. And I always just kind of went back to SSH and Vim.
I think it's just easier. Like it's harder when you first start.
It is,
and
really
you're like,
difficult.
why do people do this? Why are they like sadists? And then all of a sudden, like you're like, I'm just gonna Vim into it, and you're like, they've got me.
I was a baby developer, learning just like what terminals were. And my onboarding when I started at Disney Animation, someone came and they did the onboarding, and I watched them navigate Vim like a ninja. And I was like, I do not know what you did at all, but I want to learn how to do that because it was amazing. And ever since then, I've been hooked.
I was like, I'm never going to be able to do that. Now I'm just like, oh, let me set the number lines and do this real quick. And I'm just like, I love it. It's just so easy. Yeah,
the muscle memory is so, you don't even have to think about it after doing it for a while. So
it's definitely a hard start. So if y'all just started, don't feel bad.
And Vim has built-in tutorials. Like there's a game built into Vim.
Really? There's a Vim game?
Yeah, it's just built in. I don't remember what the command is. Wait, I'm going to look it up now.
I'm going to give that to my kid. I'm trying to get him to type more.
Vim Tutor. Is that it? Yeah.
I didn't know that was a thing.
Vim Tutor, and it'll start going through like, hey, let's do keyboard shortcuts. Let's show you how this works, and that just kind of launches it in, and it's movement and some small things like delete a word, go to insert mode, that stuff. It's hard to get used to at first, but I've been using it for 20 years, and it's definitely paid off for me.
I can't believe you've been like an engineer for 20 years. Not because like I always forget that you're older than me, and I'm like, but how compute the like numbers? Now you're really going to look younger because you have no hair.
I'm trying to stay young,
You went from crowd surfing to dad jokes, Justin.
It is the circle of life.
It's okay. We still love you, even if you're getting old. You're going to be the old man at conference.
That's fine. Like I remember when I was a kid at concerts, and there was always someone that was older, right? Like at that time, it was like 30 or something like that. You're like, oh, they could be 30, they could be 40, they might be 50. I'm like, why are they here? They're so old. I'm like,
you called people old, now it's come back to you.
Yeah. I was just at a hardcore show in Japan like 2 weeks ago, and it was amazing. And I was the old person, and that's
now
fine.
You're the old dude. It's so cute.
It's fine.
You're gonna be like the hardcore grandpa. It's going to be so adorable.
It's going to be good times.
And Beth is going to still look like she's 20. It's going to be great.
Thank you, everyone, for listening to the show, and we will talk to you again next week.
Bye.
3, 2, 1.
Thanks for listening to Ship It with Justin Garrison and Ádám Nash. Subscribe now if you haven't already. Head to shipit.show for all the ways, or just search for Ship It wherever you get your podcasts. You'll find us. Thanks once again to our partners at Fly.io, to the mysterious Breakmaster Cylinder for these dope beats, and to Sentry. Use code CHANGELOG when you sign up and save $100 off their team plan. That's all for now, but come back next week when we continue discussing everything that happens after Git Push.